So as the name implies, mobile development involves building solutions or software solutions for what we have come to know as smartphones, which usually encompasses mobile phones, tablets, and even smartwatches. These devices are often, or they often possess slower computing resources. If you've ever used a phone with less than 1 gig of RAM before, you understand what I'm talking about. Then also for portability reasons, these you get things like responsive design, building an application that looks good on both mobile and desktop devices. Devices, but the most prominent difference is usually in their operating system. The major ones being iOS and Android, with the rest having close to 0% market share. I believe almost every one of us, if we are using a mobile phone or a smartphone, we are either using an Android device or an iOS device. As a developer, you might be required to target any or all of these major platforms, which normally influences how these products are built. And we'll be looking at types of mobile apps and how they are made. But first, let us look at the basic components of a mobile application, because this would help us in understanding what separates the different types. So I've identified, or we'll be looking at four major components of a mobile application. The first three being application logic, runtime environment, and platform libraries. Now, the application logic simply refers to the code that you write, or the business logic, the UI logic, and in most cases, depending on your architecture, your presenter logic. This definition and the language or the programming language you use in defining this application logic determines what type of app you build and where you can run them. Then the runtime environment is simply an execution environment for a particular programming language. Say, for instance, Java makes use of the JVM runtime environment, but in the case of Android, Android executes its own Java code in what is known as the Android runtime. For iOS, you have the Swift plus Objective C, which runs on the Objective C runtime. Then one thing this runtime also provides for us, platform libraries basically gives us tools to target the services, the hardware components, and all the core components of each mobile application. So Android development, for Android, you get something like Java or Kotlin combined with the Android runtime, then the Android SDK, which gives you all the APIs and tools you need to build for Android. Then for iOS, you have Objective C or Swift plus the Objective C runtime plus the iOS SDK. Then there are also other programming languages you can use to write code for mobile apps. You have JavaScript, that C Sharp, HTML, CSS, and even C. So the way we combine them determines how our Android or how our applications are going to turn out. Then another key factor is the rendering engine. The rendering engine. I have um, a short line here. It says from code to pixels or your graphical output. Basically, the rendering engine is what takes the code you have written, processes it, and turns it into the pixels or the display you see on your phone. Just like the sample I have here, you have a HTML code goes through the rendering engine. Then from the rendering engine, you then have your final display. The combination of the rendering engine and the application logic is what gives you or is what basically defines the different types of applications we're going to be looking at now. So the first one are native mobile apps. The native mobile apps are apps that are built for a specific platform. They have code that is written to target that platform and that platform alone. So if you're writing a native app for a particular platform, you expect that that same code will not work for a different platform. So you're building for Android, you make use of Kotlin or Java. You're building for iOS, you make use of Swift or Objective C. One good thing about native apps is that they are very fast and performant. This is because they are built or the everything, both the rendering engine, the platform libraries, and the application logic as is portrayed in this diagram now are all in the same runtime environment, which is the native runtime environment for the application. So in this case now for Android, you're talking about the Android runtime. For Objective C, you have the Objective C runtime with the rendering engine, which implements the or which uses the native libraries of the platform to display your graphics. Then you also have the platform libraries there and the application logic all in the same language runtime. And this also gives us an interactive and intuitive display and also makes it easier to interact with the device utilities. Then the second group of applications are what we call cross-platform applications. Cross-platform applications are generally built to work across multiple devices. There are basically two types, or you can reduce them to two types. You have cross-platform native mobile apps. These are apps that allows you, or these types of apps allow you to write your application logic in a different programming language that is not the native programming language of that platform. So if we are talking about using a language like JavaScript or C Sharp even, but the rendering engine for this type of application are still executed using the native rendering engine of the platform. So we are still talking about using Android views for Android and the equivalent rendering system for iOS. It also utilizes the platform or the specific platform libraries that gives you the device utilities for each of those platforms. They allow for faster development. This is because you write once, you use twice. And one thing that makes it possible for these programming languages to be used in every or any platform is a cross-platform language runtime. Say, for instance, if you want to build an application with C Sharp, you need a runtime that can execute C Sharp on that particular platform, which in this case is the Mono VM. The Mono VM gives you a runtime environment that you can execute C Sharp code or that you can execute .NET and all its languages that it supports, all running on the Mono VM. So this same VM now can be used cross or across multiple platforms, giving you the power to write once and use multiple times. The major libraries in this category are Xamarin and React Native. Though they have their slightly different implementations, but they all follow this same pattern with the application logic in different runtime environments and the rendering engine. Then the second type are hybrid mobile apps. Conventionally, when you're hearing about hybrid mobile apps, we normally hear something like yeah, apps that are built with HTML, CSS, and JavaScript. While in a way this is correct, it does not really encompass the whole idea of what a hybrid app is. So basically, a hybrid app is a app that renders its view or layout in a different runtime environment than the native platform. So if you look at the diagram now, you see the native language runtime for each platform. Um, like I said, Android runtime for Android, Objective-C runtime for iOS. Then you also have a cross-platform language runtime where you have your application logic, and there you also have the rendering engine. Um, a good examples for this are the Ionic framework and Flutter. Normally, hybrid apps are expected to be slow. Normally, they are expected to be slow, but a framework like Flutter improves speed and agility by creating or making its own cross platform language runtime to be a native language like C. So if you write a code in that, for instance, that compiles down to the C that compiles down to the C language, and C language or C++ language executes natively on this architecture. Like Android can execute C natively, both iOS too can execute C natively. So that is how you achieve a hybrid mobile app. But in the case of Ionic makes use of a web view. So basically, your browser, the same implementation your browser makes use of is the same implementation the Ionic framework makes use of, but it places wrappers around the native language runtime that allows it to communicate with the specific platform libraries. Then two other mobile apps worth mentioning are the progressive web apps and what is becoming prominent these days, no code applications. For progressive web apps, these are apps that they are basically your conventional web apps as we distribute through the internet. But you can provide native features like push notifications, and most of the other native features you have. You can update automatically and makes it feel close to a native application. They rely on the browsers, on the browser implementations on each of the various devices to function. So if you have a PWA on your Android device, for instance, it is making use of Chrome to execute this logic and this environment. Then you also have no code apps like Microsoft Power Apps and Happy Pie. These apps essentially help you build line of business applications. So that's because you can easily write code and develop solutions without you can easily develop solutions without writing in a single line of code. In this way, you can build specific flows and logic patterns that relies or that are specific to your organization and your business needs. So that's it for the type of mobile app. Now we'll be looking at our main goal for this course or for this session. For now, I'll just be giving an introduction to Kotlin programming language. Then in subsequent sessions, we shall go much more deeply into the language features and all you can use it to do. So what is Kotlin? Kotlin is a modern programming language that makes developers happier. This seems oddly specific, but coming from an Android user specific, from an Android user's uh, perspective, when we were writing Java applications, we normally struggle with things like the null pointer exceptions, all the other headaches that Java gave us then. So Kotlin is basically a language that was built upon past experience and um, stress or struggles that developers had to go through while building applications using languages like Java. Make developers happy when using Kotlin. The first is an expressive and concise code where you are able to focus on expressing your ideas and write less boilerplate code. Say, for instance, now you can take a look at the implementation of a Java data class. A data class is basically or simply a class definition which provides getters and setters for a particular property or properties of a given class. Kotlin allows you to express the same Java just in one line using the data class representation. Then you also have writing paper code. By default, Kotlin is a null state. You can see a screenshot of a little error that your log output can throw at you when you hit the null pointer exception. This error is not always beautiful. It's not always beautiful to see. So with Kotlin, you can avoid this unnecessary error by declaring your variables to be either null. Whenever your variable is declared null, it can be determined non-nullable. It can be determined at compile time if that variable is going to be null or not. Whereas in Java, where you can determine if that variable is null or not. Then we also have interoperability between Kotlin and Java. Kotlin compiles down to Java bytecode, which essentially brings to the same representation as Java. Relationship enables you to call Kotlin libraries from Java and call Java libraries from Kotlin. This can Kotlin into your existing Android application without worrying about in the operation between the two of them. Then another important feature will have structured concurrency. How the language implements asynchronous programming. It makes use of coroutines. Coroutines is a Kotlin package that enables you multiple threads or asynchronous programming. The process of using Java for asynchronous programming or executing multiple threads is often tedious because execute UI logic, which is known as the UI thread. You can also spin up other threads to carry out additional processes. Whenever you want to communicate between the two threads, it becomes a problem and it often requires some boilerplate implementation. But Kotlin enables this to be carried out. Kotlin is known to be used natively to build Android apps, which makes it a very, very good solution for default programming language for Android. It can also be used to build server-side applications using the JavaScript runtime environment, using the Java runtime environment. It can also be used to build web using Kotlin JS and executed in your browser. Then you also have building for that assembly, we known as Kotlin native. Kotlin native allows you to Kotlin through the Kotlin compiler known as Conan, and then goes through an LLVM on straight on your hardware architectures without relying much of any runtime environment, deploying runtime VMs and all of that. So to run on any single or almost every single platform, like I mentioned, iOS, Linux, Windows, Mac OS. So basically, Kotlin gives us the power and where so this is how powerful Kotlin can be when used properly. So that will be all for if you want to get started with Kotlin, you can head over to developer.android.com/Kotlin to get Android specific implementations of Kotlin. Or if you want to learn the core language, then .org, and there you'll be able to find every single documentation and references you need to work with Kotlin. Alright, thank you.